Good morning again, and thank you everyone for joining us. If it's your first time coming to one of our webinars, welcome. And if it's not your first time, we're glad you're back. Thanks for joining us all today for the Unmanned Aircraft Systems webinar. This is part of one of AirTAP's webinar series, and we'll talk a little bit about that. I'm Natalie Niskanen. I'm a program coordinator with AirTAP. Just a quick overview of AirTAP. We help Minnesota's public and private sector airport professionals improve the safety, quality, and efficiency of airport operations and increase the use of new navigation materials, practices, and technology. And we are sponsored by the University of Minnesota Center for Transportation Studies and MnDOT's Office of Aeronautics in partnership with the Minnesota Council of Airports. We have several training events that occur throughout the year. Those include the annual Minnesota Airports Conference, as well as an annual Wildlife Hazard Control Workshop. And then we do have electronic and print newsletters available that we send out on a regular basis covering airport management and relevant content that is applicable to all Minnesota airports, large and small. So like I said, this is part of our winter technical webinar series. This is the last one in our series this year, but all of our previous webinar recordings are available on the website for you to view or send to your airports. We do still have some AAM webinars coming up. The next dates are May 15th and June 12th. So registration is TBD on that, but you can always check out previous recordings if you missed any of those. And then just a couple quick plugs for our upcoming events. Airports Conference, hope we see you there, April 23rd to 25th in Mankato. And then we also have the May 7th Wildlife Hazard Control Workshop. And then just a quick housekeeping note here. We really value your feedback and would appreciate after the webinar if you would just take a few minutes to complete the survey that's going to pop up in your screen after the webinar is concluded. And we just appreciate any comments or feedback, anything you want to see from us. We really do read these and take your feedback into consideration. So thank you in advance for your participation with that. And then just for today's webinar, we are going to be utilizing the chat. So if you look down on at the bottom of your screen, you can click on the chat window there. You can chat with just us, or you can chat with everybody. But feel free to put your questions in as you go along, and we'll answer those as we are able to throughout or at the end if needed. We can circle back on a topic if it's kind of off topic. So with that, I'm going to turn it over to Nate Williams, who is an AV rep with MnDOT Aeronautics and is also the UAS coordinator. Thanks for joining us today, Nate.
Good morning, Natalie. Thank you, everybody, for joining us. Let me get my screen share going here. All right. Can you see that, Natalie?
Yes.
All right. Excellent. Well, welcome and thank you, everybody, for joining. As Natalie said, my name is Nate Williams. I'm the UAS coordinator for MnDOT Aeronautics. And I'm going to start this whole thing off with a little question for you. Today's webinar is about unmanned aerial systems. So if you want to put it in the chat, do you think there are more UAS or manned aircraft registered in the United States? And do you think there are more remote pilots or manned aircraft pilots in the United States? So if you can put your answer in the chat, we will circle back on that here in a second. And while you're doing that, I'll talk about who I am. Long history in aviation and flight. I am an airline transport pilot, airplane, multi-engine land. I've got a couple of type ratings under my belt. Flew cargo and medevac through North Dakota and Minnesota for quite a long time. I have my glider rating. I'm rated in seaplanes. I went to the University of North Dakota and their aerospace program. I've been dealing with UAS since before it was UAS, when we called them RC airplanes. You can see my little fleet of goofy foam things there that I like to have some fun with. And then been a 107 pilot since, well, you could be a 107 pilot. So let's answer the question. Look at the numbers of UAS and why we're even here. So 1 million total UAS are registered in the United States, of which 412 of those are considered commercial operations. That compares to about 220,000 total manned aircraft registered in the US. So it is 5 times more UAS. There's a lot of them. The FAA has got about 20,000 words and regulations written around UAS. That's peanuts compared to manned aviation. There's about 500 civil and government use drone manufacturers in the world. And then there's about 1,000 companies right now providing various levels of drone services, everything from flying the drones the whole way down to manufacturing and consulting. So quite a bit more UAS. So by the numbers, here is remote pilots versus regular pilots. This doesn't include student pilots, but you can see in the graph that as of 2024, which is when the FAA's data was put out, we had about 500,000 roughly manned aviation pilots in the United States and just over 400,000 Part 107 remote pilots. So the trend, however, is increasing quite steadily. And you can see the trend is plotted out to where by 2027, we are going to have more remote pilots than we are manned aviation pilots. Now, that's only Part 107, which is a commercial UAS operator, commercial remote pilot. If you count recreational pilots, which are required to take the trust test, then the number is 1.4 million remote pilots. So it is a significant, significant difference. And this is something new to all of us. It is game changing for the industry. So I'm talking a lot about SUAS. Let's define that. So what is an SUAS? It is a small unmanned aircraft system. The S stands for small, and it is up to 55 pounds. Both of these aircraft in the pictures are small unmanned aircraft systems, everything from the DJI T10 agricultural spraying aircraft you see on the left to the DJI Mini 4 Pro that you see on the right that is a photography and videography drone. In fact, some of you probably have something very similar to the one on the right. There's also two major types of UAS operations that we deal with, recreational and commercial. Recreational UAS is governed not under FAA 107, but under a bill and requires a test called TRUST, the Recreational UAS Safety Test. That's all it is. And so it's a quick online thing that people take, and then they have to have that in order to fly. And that's it. If you're flying recreationally, that's all you got to do. You do need to have remote ID, which is a broadcast on Wi-Fi and Bluetooth bands from your aircraft if you're flying, and it's over 249 grams. And then on the right, you can see an example of what would be a 107 operation or a commercial operation. A lot of people don't realize that their operations are commercial. When you are flying a UAS and you're taking pictures and you post those pictures on YouTube or anything monetized, the FAA considers that a commercial operation. So for a commercial operation, you have to be registered with the FAA. You have to have a Part 107 pilot's license. And in the state of Minnesota, you have to have a commercial operator's license, and your drone has to be registered in the state of Minnesota. So there's a lot more to deal with in 107 versus recreational, but we're going to focus on 107 through this webinar. So UAS is part of the advanced air mobility concept, Part 107 specifically. It is the basis for unmanned advanced air mobility. We all know that that's kind of where we're trying to go with advanced air mobility, is the concept of the air taxi that you just call and it remotely comes down and it lands at your house. You climb in it and it flies you to the airport. Pretty cool. But that's part of the FAA's crawl, walk, run approach. Is right now we're crawling. We're doing things with small UAS to build up for something like that. And then as we continue to prove out small UAS, we can move up to carrying people with UAS. And this small UAS concept will continue through, even with that, it continues for things such as package delivery, drone as a first responder, and a lot of different ways that unmanned will be part of our national airspace system. What we're doing right now with small UAS, with Part 107, is we are proving the safety of operations in the national airspace system. That way we can move forward with urban air mobility, regional air mobility, and all of the concepts of advanced air mobility that you see on this map. You can see different cargo deliveries. You can see on-demand air taxis. You can see medical transfers are all part of this. And those are going to start as manned. They're going to start with a pilot in it, with the eventual goal of moving forward. So the question everybody needs to be aware of is UAS going anywhere? No, it's here to stay. It's only going to get bigger. So what are we doing in Minnesota? What's our strategy? Well, first of all, at MnDOT Aeronautics, we're using our internal operations through MnDOT to drive our numbers and statistics. We actually use UAS quite extensively across MnDOT. We're going to take a look at that. We're also looking at external partners and external use cases to figure out what UAS looks like across Minnesota, what we need to do to support it from the concept of MnDOT Aeronautics, and some of the lessons we've learned about operating them safely. So that's what I want to dig into here today, is look at some of these numbers, look at some of these flights, and what we've learned within MnDOT Aeronautics, what we've learned within the operations at MnDOT, and how that applies to the greater UAS community. Whoops. So here's our by the numbers. What did we do in MnDOT Aeronautics in 2024? 1,100 total flights, roughly 950 flight hours, 355 different missions. We've got 53 active pilots and 120 visual observers. So a visual observer is a second crew member that goes out, and when the remote pilot is looking at the screen, taking pictures or whatever they need to do, the visual observer is making sure that there's no manned aircraft encroaching on the area. So what do all these numbers mean? They seem relatively low. You look at an airline or something, this is peanuts level of hours. But for UAS, this actually makes us one of the largest commercial drone operators within Minnesota. We have a very extensive fleet of drones and pilots. Our hour counts are, only 1,000 hours. Well, you got to think that we're not flying from point A to point B. We're flying tops 20 to 30 minutes per flight, and then doing missions around local areas. So this is what you would expect, but it actually does make MnDOT one of the larger commercial drone operators within Minnesota, which I was quite surprised to find out. But it's true. So what do we use these things for? Well, some of you may have seen one of these things, our LiDAR obstruction data from our airport inspections. We can take a drone, and we can fly using a light detection and ranging sensor and look at obstruction data. And it gets much better and better quality information to the various airport managers, to some of you, and to all of our surveyors of what is happening around the airport. There's centimeter level survey data available. LiDAR can penetrate through vegetation. Typical on-the-ground surveyor standing at the end of the runway using a laser to figure out where the treetops are can only see the ones that are closest to them. They can't see the ones in the back. If you take a look at, I'm not sure you guys can see my mouse, but maybe you can. If you look at number 8 here, and then this big blotch around number 12, the big blotch is going to block off the view from the runway of number 11. So that might not have even gotten caught during a airport inspection. So that obstruction wouldn't get pulled until the next time it came. And then you got to go back out there again. So significant change in how airport inspections work. We use them for bridge inspections. My favorite picture here. We do visual and thermal inspections of bridge infrastructure. It is part of our infrastructure inspection mandate to examine these bridges regularly, and this not only speeds up but increases the safety of our operations. During the Rapidan Dam breach in Blue Earth County, the drones were key and pivotal. We sent our bridge inspectors down there and did critical infrastructure inspections immediately, and we were able to quickly assess the damage to any of our bridges and determine whether they could be open to the public. And that was enabled by drones. Otherwise, we would not have been able to do that. Our current mission involves the use of what we call snooper trucks. They're big trucks that drive along the road. They have a huge arm with a lift on the end of it that people stand under. So you have to be able to put the truck on the bridge to be able to look underneath it. So it increases safety, it increases the speed, it increases the efficiency. We do herbicide application. You've seen this picture before in this presentation, but this is one of our DJI T10 aerial application drones. This is a very unique regulatory pathway. It's both Part 107 and Part 137 agricultural operations. So we have waivers, various waivers to be able to do this. So what we've done with herbicide application is we now can do a targeted aerial application. Before, we would have a truck driving down the side of a highway, typically with a crash truck behind it, and then another blocking off the lane to do bulk spraying of noxious weeds alongside the highway. Well, now we can use the drone. We don't have to shut down lanes of traffic. We don't run the risk of our operators being hit by public vehicles. We also reduce the amount of exposure our applicators have to the actual herbicides, and we can reach steep slopes and other hard to reach areas. We have LiDAR mapping. So if you're familiar with RTK or PPK workflows, so kinematic workflows, we can pull our mapping down to 1 centimeter level accuracy. So survey quality accuracy using the drone. It's used everywhere. We use it in pre-construction, post-construction, land surveying, bike and pedestrian path layout. We very recently did a flight in Moorhead, Minnesota, for the new bike path that is being laid out near I-94. And that was to figure out the grading so we know exactly how much material we need to remove and exactly how much material we need to add. We also do photogrammetry and 3D modeling. So the concept of what we call a bridge twin. So we can go out and take photos using the drone of a bridge and then create a 3D model from that a bridge engineer or bridge inspector who needs to know something doesn't have to keep going back out to the site over and over again. They now have a full, complete, up-to-the-date 3D model of a bridge that they can zoom all the way in on when needed. We, of course, use these things for photography and videography. I'm sure you've seen on the MnDOT website, on MnDOT Aeronautics, anywhere that you look with MnDOT, if you see an aerial picture, it was done with a drone. It was done with UAS. We most recently are doing something called Scene Safe, which is training for first responders on accident scenes. And we use drones to shoot a significant amount of video and photography for that. So what other use cases are there outside of MnDOT? A lot. There are so many use cases for unmanned systems, agricultural and forestry, analyzing the health of trees and looking at fire risk. Infrastructure inspection is a huge one. Power, going along and looking at power lines, oil, gas, utility. There are airborne methane detectors that can fly along gas pipelines. Insurance is a big one, doing photography and videography for insurance. Package delivery, I think everyone's heard about that one. Real estate, doing photography and videography, tracking wildlife, and the list goes on. Things that you would never think, oh, we need to go up in the air for. Think about just doing an inspection on someone's roof after a major hailstorm. Before, ladder, person on the roof. What if it's a steep roof? What if someone falls off the roof? There's so much danger involved with that. Well, now we can just fly the drone, get real up close and look and take pictures. So that's what we're using these things for. Let's talk about what we've learned internally about how UASs, what the issues are with UASs. So these are incidents and occurrences. This is breaking a prop, crashing a drone, something caught in pre-flight. In general, MnDOT hasn't had an accident with drones. We have a pretty safe operation, but this is kind of stats of lessons learned of internal. So occurrences per 1,000 hours of flight over the last 5 years. So you can see where our main level of occurrence is. It's in mission planning. Site prep pre-flight, we had none. Takeoff and landing, we had one. Near obstruction flying, we had one. And we had 2 incidents and occurrences in post-flight. So what happened in mission plan? Well, the big one is not knowing about nearby airports that aren't in controlled airspace. So that's situational awareness. So let's say you're taking off near Henning Airport. Does the drone operator know that Henning Airport exists and that manned aviation might be operating out of that? Do they know that there is a helipad nearby that might have medical helicopters coming in and out? We need to make sure that they know that. Knowledge of weather and limitations on equipment. Is it too cold to fly? Is it too hot to fly? And then ensuring that NOTAMs and TFRs have been checked. What happens during near obstruction flight and takeoff and landing? This actually typically comes down to equipment issues from what we've seen. Certain drone manufacturers in GPS denied environments, especially over rivers and water, the flight control system becomes very unreliable. There's a drone in this picture. It's up here under the bridge deck being checked out. And then post-flight, what are the post-flight incidents? Most of them are data incidents. So the operator gets done flying the aircraft, they come down, they go home, and they realize that they never actually clicked the record button, or they didn't have an SD card in there, or the data they took became corrupted. And so it becomes useless, and they have to go out and do the flight again, which changes the risk level. It also puts them on a deadline. So what have we learned about operating UAS just looking at our internal operations? For most people, the UAS is a tool, not a job. This is a major change from all of us in manned aviation, where the airplane is our job. It is what we do. It is what we think about. For a lot of people, the UAS is a wrench, a very, very highly regulated wrench. People are real estate agents, bridge inspectors, photographers, maintenance workers. That is their job. The UAS is a tool. It's the wrench that they pull out. It's just the world's most highly regulated wrench. Training is vital. There are so many gotchas, everything from software to FAA rules, that a good training curriculum is required for people to operate UAS safely. Currency is even more vital. If you're not doing it every day, if it's a tool that you don't use every day, the knowledge goes away quickly. The example I like is I have a very nice DeWalt planer that I don't use as often as I would like, but I do woodworking cabinetry. And I pulled it out the other day and I'm trying to adjust it and I'm going, oh man, it's been a while and I had to relearn that. Same thing with the drone. And then lastly is trust your operators. There's a lot of regulation in this, which seems to be operator centric. And we need to learn to trust our operators to do the right thing and maybe move our regulation a little bit higher. So what are we doing in MnDOT? What did we learn and what are we doing with all these lessons learned? So in January 2025, we put out a new operations policy for our internal operators that added training requirements and clarified all the additional requirements we have for operators. We made it much easier to read. And then we made a recognition that UAS is a tool. It's not a job. In Aero, UAS is our job. So we are going to provide the training for UAS internally. We also created a new operations manual in March 2025. So just last month, that new operations manual came out, adding a concept called level of trust. Level of trust is the concept that the more you fly, the more experience you have, the less scrutiny you need, the less person looking over shoulder you need. We added the role of a flight instructor in our operations manual. We changed our currency requirements from this. We said, okay, we need to have some sort of level of recency of experience. We changed our training from biannually to annually. And then we changed our focus from mission planning instead of stick time, which is a huge change for manned aviation. UASs, they fly themselves. They simply do. I can take a UAS, I can put it in the air beside me, I can go have a Snickers bar, use the bathroom, come back out, and UAS is going to be in the same place it was. So the stick isn't as much as important as it is in manned aviation, where you're twiddling the sticks. The mission planning is by far the most important piece. So let's expand this. Let's talk about the rest of Minnesota. So first of all, what does MnDOT do? Who are we for the rest of Minnesota? Well, first of all, we do aircraft registration, FAA registration. So we have an aircraft registration for drones, and we want to make sure that you, number one, have also registered your drone with the FAA, and that you have the appropriate liability insurance, and we have a sales and use, basically a use tax for it. We also license commercial operators, so anybody that's involving aircraft that advertises or offers service, and we want to verify that you have the proper insurance for doing that. MnDOT is not here to create regulations. We're not going to try to regulate the airspace and what you do with your drone. We want to be here to help. Looking externally in Minnesota, we did a survey and we asked, do you know someone or do you or someone you know own a drone? 74% of people said, yeah, that's high. So what am I getting at here? Pretty low barrier of entry. If we did the same survey with do you or do you know someone who is a pilot, number's probably a little bit lower. How's your drone used? 62% recreationally, and then the rest are commercial use cases. We look at FAA enforcement actions. We looked at 70 different enforcement actions that the FAA took against drone operators. 5 of those resulted in certificate actions. So this means that only 5 out of 70 cases were deemed to be negligence or needing enforcement. The rest were compliance, education. So what are the most frequently violated fires by remote pilots? No remote pilot certificate. Careless or reckless. Drone not registered. Not having currency or recency. Or someone operated in airspace without authorization. That seems familiar. Let me pull this slide back out again. Mission planning is the biggest issue in UAS. The issues we're running into, and the conclusion I want to draw here, is lack of training and lack of knowledge. We have a hard problem to solve. UAS is a very highly regulated thing with very high risk, but also an extremely low barrier to entry. I can't think of another industry that's like this, where you have a mix of commercial and recreational users that are operating in a system like the National Airspace System. Maybe cars when they were first introduced, but then the barrier to entry was much higher due to price. You can't go out and buy a scalpel and suddenly be a surgeon, but you can just go to Best Buy or Target or any store and buy a drone and fly in the National Airspace System right next to MSP Airport. And if you don't know, you created a problem for yourself and for someone else. So what do we do? What do we do? Well, first one, educate, educate, educate. It is the most important thing that we can do. We need to make a major culture shift throughout the state of Minnesota and the United States that has someone go, oh, you bought a drone? Oh, did you register it? Kind of like, oh, is your car registered? Same thing. It has to be something that people just know. So here I am telling you guys that commercial drones need to be registered with both the state and the FAA. And if you tell one person, I've succeeded. We do lots and lots of education and outreach events. That's what MnDOT's here to do. We're not here to create regulations. We're not chasing people down with enforcement actions. We want to go out and help people, and we want to educate people. We want to work with organizations like the Civil Air Patrol. We want to work with the colleges and universities like University of Minnesota to get out there and talk to people about this. What else are we doing? Well, we're in a bunch of multi-state work groups. We work with Tennessee DOT quite extensively, Washington DOT, North Carolina DOT, North Dakota Department of Transportation. North Dakota is home to the Northern Plains UAS test site, one of the leading UAS areas in the United States. So we have that advantage right up on our northwestern border. So we want to engage, and we want to try to figure this out together, not just individually. And then we can adjust our rules to help as technology changes. We currently have a bill with the Minnesota House and Senate that involves drone swarms, not to regulate them, but to make it easier for them. Rather than them having to register each individual drone in their swarm, we're changing it so that they can register the whole swarm as a whole. The technology has changed, so we're going to change with it. So what else can we do? Well, MnDOT is a resource for anybody that needs help with unmanned rules, regulations. Someone wants help setting up a program. They want to have some sort of shared services agreement. We can help with this. We are doing our best to reach out and educate. We are also looking at the future. How do we enable beyond visual line of sight operations? That thing we talked about with drone as a first responder. Huge, huge piece going forward for us. What are we doing with that? How can we do it? We're working with companies like the Northern Plains UAS test site and Vantis to figure out what does BV loss look like for the future. So what can we do for you is a good question. Even if you're not a UAS operator, if you have questions regarding rules, regulations, anything, we can help. We're here. Unmanned is here to stay. It is not changing. We want to work together and make it safe. So does anyone have any questions for me? All right, well, thank you, everyone. Thank you, Natalie.
Thanks so much, Nate. Looks like you have your email there. If anyone has questions, I can reach out with your questions that you might have if you're thinking about them. Thanks again, Nate. Thanks everyone for joining us. Hope we see you at the airports conference in a couple of weeks. Thanks so much, Jeff. Glad you joined us here, and have a great rest of your day. Thanks, everyone. Bye.